And until now, you might have been under the impression that this is the Blue Sky session. The last presentation, however, is about Sardana. Do you have any video in the slides? No. Okay, good. Then this will work. We have Vanessa da Silva with us and Zbigniew Reszela, who are going to be talking about enhancing Sardana continuous scans.
Okay. Good morning, everyone. So I work at Alba Synchrotron from Spain.
And I am from the software group at Max4.
Okay, so in this talk, we will start with a little bit of history of continuous scans developments in Sardana to put you in the context. Then we will talk about the motivation for next enhancements. Then we will report on the status of development and present you some applications that we plan to use, these new features. Before that, let me introduce you Sardana. So it is a scientific SCADA suite. It is built on top of Tango control system. It is developed in Python and it consists of 4 pillars. So since it's using Tango, it has client-server architecture. On top, we can see the client applications, which are Taurus graphical user interface, which is based on Qt, Spock, which is IPython-based command line interface. And on the server side, we have environment for running user macros called macro server and a device pool where the access to the hardware is implemented. All these components are extendable with plugins. And last but not least, behind Sardana stands a strong community of users and developers. So now a little bit of history of continuous scans developments in Sardana. So Sardana is a long-lived project. Since the beginning, it came with a scan framework, and this framework was built on top of generic interfaces to instruments like motors, experimental channels, with groups or pseudo elements, and it was and still is a great solution for running step scans. Then we added support to continuous scans, and we were not starting from scratch, so we reused most of the elements from the original design, and we added new interface for devices with synchronization capabilities. We call it trigger gate. We established relationships between the synchronizers and the experimental channels, and the central point of this design was the synchronization description, which at that time was unique for the whole scan. Then we focused on improving integration of detectors by allowing to report references to data instead of data itself. We improve integration with HDF5 format, and we achieved to smoothly integrate detectors either with Lima library or in any other way. And after that, continuous scans development were put on hold because we were focused on migrating code to Python 3 and on developing the configuration file format to Sardana. Now Vanessa will explain you the motivation for future enhancements.
So after a while, even though the community had a big effort to support continuous scans, those features are not enough to support all the requests and new kind of use cases we receive from the beamlines. So this happened because the beamlines are always becoming more complex, new end stations are being built, new machines like Max4 are becoming full operation. So we start to have a new challenge and new opportunities with this kind of new facilities. So one of the use cases we started to receive was to perform multi-techniques experiments running either in parallel or sequentially, and also detectors running with different data acquisition rate as a good example. So to understand which features or how we could improve the support to continuous scans in Sardana, it was organized a continuous scan workshop at Solaris, where we gathered the whole Sardana community, as well participants from other facilities and other scan frameworks as well. So as a result of this workshop that was really nice, we managed to make a short and mid-term roadmap. And from this roadmap, we have 3 priority features that we would like to implement soon. And today on this presentation, we are going to discuss better the details of these features.
Okay, so first one is a concept of multiple synchronization description. But before that, let's explain what this sync description is. So it is a data structure which represents how the elements will act during the scan. So previously there was only one, so all the elements, they had to obey the same synchronization description. This sync description is calculated by the scan framework from the characteristics of the elements, their parameters, and the user input that they specify. And now we have added another layer to this data structure. So we can aggregate multiple sync descriptions, and we refer to them with the name of the synchronizer element that will generate these synchronization signals. And thanks to that, it will be possible to execute scans, for example, with detectors acquiring at different pace. Next enhancement is about integration of the shutter element. So previously, it was possible to use fast shutters in continuous scans, but this was done on an ad hoc way. Yeah, so for example, in a macro code or in a custom controllers for trigger gate elements. And we aim to integrate shutters independently of the synchronization hardware. So we have added in Sardana a new element type, which is called shutter, which is basically an aggregation of shutter characteristics like time to open the shutter, time to close it, or configuration in which mode we would like to use the shutter. Then the user simply adds a shutter element to the measurement group in the experiment configuration widget, or remove it when he does not want to use the shutter. And the scan framework, based on all this configuration, is capable to calculate the synchronization for the fast shutter. And last but not least, enhancement is in terms of data publishing into an in-memory data store. So here on this sketch, we can see the original data flow in Sardana. So you can see it with this red arrow. And the data were traversing the whole system from the hardware controllers up to the recorder plugins, which were delivering it to the final destination. And we wanted to tackle different problems with this. Yeah? We wanted to minimize the stress on the macro server, make the data available to external consumers, reduce the stress on the Tango event system, and enable external data composition, which will be very interesting when using these multiple synchronization descriptions. So we opted for using Redis database for that, which is very popular in the community. And we do it using the Bliss data library from the SRF. Currently we publish data from the very upstream part of the Sardana, which is directly from the device pool, which using the Bliss data library publish data to Redis database. And now we pass to the applications that will use these new features.
So now we are trying to discuss which applications would benefit a lot from these new features in Sardana. Let's see if I know how to use this. Yeah. So the first use case we have from Axor is a continuous scan position based. And the biggest difference of this one, that's a multi-technique system where different techniques are performed sequentially and fully orchestrated by hardware. So this use case comes from an X-ray spectroscopy Beamline, which their main experiment is basically scanning the energy from their double crystal monochromator. And on this case, nowadays, they can do energy scanning very fast in sub-second resolution. So meaning that launching a new scan takes more time to open the file, arm the detectors, than to actually scan the energy around a certain energy edge. So the idea here is to make it possible for the user to configure many different techniques in a sequence, like XZane is around an energy edge, XRD, then XZane is another energy edge, XRD, and another energy edge. And all these configurations going to be configured into the hardware. So on this case, we use ACS motor controller, and we are going to use its feature for trajectory. So ACS provides the possibility of configuring its buffer with the functions for the trajectory and the whole orchestration. So we don't even need an abstraction layer in Sardana for this case. So we fill all the trajectory inside ACS, and then we use PandaBox to generate triggers based on positions. And on this case, you're actually generating gates. And then it's so this way the user can perform many energy edges, many techniques, and many repetitions only fully driven by hardware. So experiments like in situ, time resolved can be performed without requiring a new relaunch or a new file to be created. And on this case, we would benefit a lot from the multi-sync description feature, because as we have many techniques running sequentially, each technique has its own associated detector. So for hexanes, we use mostly Alba electrometer for the beam intensity measurement, and for XRD, we use Eiger. So while performing hexanes, we have the gates going for PCAP and Alba electrometer, and when we are performing XRD on the constant Bragg position, we have a gate going to Eiger. So with this new feature, it will be possible to configure the detectors to perform that acquisition in different frequencies. And if you want to know more details about this and how we implement it, come to see me on the 116 poster. And another use case from Max4 is very similar, but on this case, we are performing multi-techniques in parallel at the same time. So it's basically continuous scan, time-based. And then here we have SAX, fluorescence spectroscopy, and UV visible spectroscopy being performed at the same time with 3 different light sources. So it means as each technique is handling a different kind of signal, each detector is going to require a very different configuration, integration time, number of triggers. So here we have the timing that we perform with PandaBox external triggering for this kind of experiment. So as you can see, each detector per each technique is receiving a different pulse train. So with this new feature in Sardana, we can also solve this kind of use case very easily.
Okay, and at Alba, we plan to use these new features in the beamlines that we are currently constructing. First is the microfocus MX beamline, where we need to synchronize the fast shutter and the detector from the synchronization signals from the motion controller. One is based on the constant velocity, which is for the fast shutter, and another one is for the detector, which is based on position. And here we plan to use the feature of shutter control in Sardana. And next beamline is the fast tomography beamline, where we have to deal with many instruments. We are talking about 4 detectors, where 2 of them will be used simultaneously at different frequencies. Also the fast shutter and the chopper, and while rotating the tomo stage. So here we plan to use all 3 new features, so multiple sync description, the shutter control, and also publishing data into Redis database. And this beamline also requires on-the-fly reconstruction of tomography, and this is currently being developed by the Scientific Data Management Group at Alba by Gabriel Hover. And if you would like to learn more about it, there is a poster, and you can reach Gabriel for more details.
And as quick conclusions, we have from the use cases and from what we discussed that institutes using Sardana have similar needs for continuous scans.
And even if we use different hardware, we plan to develop together and use the same software solution for continuous scans.
And the features discussed here are currently in development and testing in our beamlines.
And finally, we look forward for the 2nd edition of the Continuous Scan workshop, and we hope to see you there.
Hope to see you there.
And I wanted to say big thanks to the community for being there on the workshop, and also in the follow-up meetings that while we were developing these new features, they help a lot. Thank you very much.
Thank you also for this nice presentation format of use cases from 2 facilities with 2 speakers. We have time for a few questions. Maybe I'll start off with one. For your shutters, so if I understand correctly, if the hardware doesn't provide a trigger, you can do this with software triggering?
Yes.
What kind of latency are we talking about?
For the shutter, we allow software synchronization, but this is for slow channels. Yeah, for shutter, we aim to control them by hardware only. Yeah, so for the moment, we don't plan to use software control shutter. Yeah?
Okay, thanks. There's one.
Yeah, your multi-synchronization is described in a JSON format, if I understood.
Yes.
Do you plan to somehow reuse this description to automatically generate this nice timing diagram?
This is a nice idea, but for the moment, it's not on the roadmap. Yeah, yeah. To be able to configure the synchronization in a graphical way.
Okay, so let's thank Vanessa and Zbigniew again, and all speakers of the session.